Our next method of solving is through our substitution. And what we do with that is we isolate one of the variables, either the x or y, and you would want to use this method only or usually when one of your variables has a 1 for a coefficient. So in this case, if we look at our second equation and we look at the y, we see that in fact it does have a 1. It is a negative 1, but it will work for us. So we're going to take our second equation of 4x minus y equal to 17, and we're going to solve it for the y. So we're going to take out, we're going to move, I'm going to rewrite, hold on. We're going to move that 4x to the other side of the equation, so we would move it as a negative 4x. So we would have a negative y equal to negative 4x plus 17. You can see we just actually did this with our graphing. And then we do need to divide out that negative. So if we divide that on out of there, we'll divide it into both of those. We end up with 4x minus 17. So we're going to take the 4x minus 17, we are going to put that into the y that is in our first equation. So we will have 2x plus 3 times the y, which we just found to be 4x minus 17, equals the 5. So we have a 3 outside parentheses, so we will distribute it. So we have 2x plus, now distribute your 3. 3 times 4 is 12, so 12x. And then 3 times negative 17 would be negative 51. Still have our 5 over here. Now you've got some like terms, the 2x and the 12x. We can add those together for 14x. Bring the others down. And now we're just going to solve this for x. So move your 51 over, so we would move him as a positive. So we would have 14x equals 5 plus 51, we would get a 56. And divide that 14 out of there, and we would get that x equals 4. Okay, and I think that's what we got when we did our graphing as well. Now we're going to take our 4 and we're going to put it back into our x. So we're going to have y equals 4 times 4 minus the 17. 4 times 4 is 16. 16 minus 17, y would give us a negative 1. So our ordered pair is 4, negative 1. So our substitution method would work just as well as our graphing. And our third way to solve a system of equation is through the elimination process. And in this process, we actually get rid of one of the variables by adding up our 2 equations. So in this case, if I look at my second equation here, I'm again going to focus on this y. It's got for its coefficient a 1. So what I'm going to do is I'm going to come over here, I'm going to take that 4x minus y equals 17, and I'm going to multiply the whole entire equation by 3. If I do that, I would get 12x minus 3y equals 51. I'm going to bring down my original first equation, which was 2x plus 3y equals 17. Now what I'm going to do is I'm going to add the 2 equations together. So if I add a 12x plus a 2x, I get 14x. If I add a negative 3y to a positive 3y, what's going to happen there? They're going to actually cancel each other out. So what have I done? I have eliminated one of my variables. And then I'm going to come over here, add my 5, or add my 51 to my 17. Okay, I'm going to add my 51. I wrote down the wrong thing. I'm supposed to write 5, so let me rewrite that. I'm going to add my 51 to my 5, and that's going to give me a 56. Again, I'm just going to divide the 14 out, and I get x equals 4, which is what we have found before. And then I'm going to have to go back and replace that into one of the equations. It does not matter which one you replace it into. I'm just going to replace it into the second one. So I'm going to have 4 times x, which is 4, minus my y equals my 17. So 4 times 4 would be 16, minus y equals 17. Move my 16 over as a negative 16, so I would have negative y equals 1, but of course we can't leave that y negative, so divide them on out, and I get y equals negative 1. So again, we ended up with a solution of 4, negative 1. So in all 3 cases, we used 3 different methods. We used graphing, substitution, and elimination. It really didn't matter which one we used. We actually got the 4, negative 1 in all 3 cases. So when you come back to class, we're gonna practice, and you're going to pick and choose. You'll be able to choose which method you like, and we're going to solve some of these in class.